So now I'll be discussing about Badminton AI analysis using LangGraph pipeline. So LangGraph pipeline is basically used to implement the Agentic AI systems for Agentic AI systems. So here I am developing a multimodal Agentic AI system for Badminton AI analysis. Here you can see the GitHub repository which I have used for doing the changes and updating the code. Here you can see the files which are required for this setup, and here I have used it on Paris 2024 final match video, badminton video. And here you can see how to run the things and everything. Here are two ways to run. One is the local implementation as well as the web application implementation. You can watch it, and whatever feels good for you, you can do it. And now let's go. Why agentic AI systems? We are having traditional AI/ML systems like CNNs, vision transformers, and LLMs. But why we are using agentic AI systems? This was the question. So every traditional AI/ML system has its own importance. But some of the common characteristics of the traditional systems were they're monolithic and reactive. They're specified for specific tasks only they are designed, and they're not having persistent memory, persistent state, and everything. So these are the disadvantages. So we are moving to the agentic AI systems. In agentic AI systems, they are composed of autonomous agents with specific roles. Like if we have a complex task, we are dividing it into uh, different roles with different agents with specific roles, and we are doing here. The agentic AI systems were having some capabilities like planning, memory, tool use, and self-reflection, which are making it different from traditional systems. So here the agents were having a plan of action, and they're also having a memories, and they'll be using the tools like LLMs, anything they can use. The self-reflection is nothing but it's like a human feedback. They'll be updating themselves by self-reflection, and they can also divide the complex tasks into small tasks. And LangGraph pipeline for badminton analysis. So basically for the badminton match analysis, we would be having a multimodal data, like commentary was an audio data for the match, and the video was a video data. So we have to parallelly process both of the things from a video, and we have to generate a report. So I have used a LangGraph pipeline for doing the badminton analysis. So this is a multimodal data integration. So we are using the LangGraph for sport analysis. Like here we have used the 4 nodes, easily connected nodes, so that they can also expandable and they are scalable. And I'm getting a granular feedback, like with every pin to pin. I'm getting the granular feedback, and I'm also getting feedbacks, like different feedbacks on different perspectives. Like so the feedback for the player, feedback for the coach, feedback for the parents. And here we are getting a holistic view, like we are combining the video input, that is the player movement, and the audio, that is a speech transition, for the better understanding. And we have used the linear 4 node line graph. As I've said, this is automated, and we are getting the granular reporting. And this is a high level overview of the system. So the input is badminton match video. We are processing the video frames and well as the audio parallelly, and we are getting the data, and the data will be sending the Gemini model, and it will be giving us the output of text and PDF reports. So this is the architecture. So we'll be providing the match video, and parallelly frame extraction and pose detection will be done, and parallelly audio will be done. The data which we are getting from these two will be sending to the Gemini model, which will be used to generate the report for different role based, like player, coach, and parent based. So here you can see we'll be giving the video input, that will be done some pre-processing and everything, and frame and audio extraction will be done. And we will be entering into the LangGraph 4 node linear LangGraph thing. And at the last, we will be having a report generation. This is the detailed technical implementation. So we are having the 4 nodes. From the starting, we are discussing about the 4 nodes of the LangGraph: the video processing, audio processing, data integration, and report generation. So why we are using LangGraph is like it's easily integratable with the Python ecosystem, and it's a graph-based approach which will be storing the data. Memory management is high here. Here we can see the we will discuss each node's importance. Video node is like analyze video frame by frame, and it will be using the media pipe and OpenCV to detect the human poses and calculates everything which is required for the prediction of the report generation, and it will be giving a structured JSON with timestamp, key points, and performance metrics. And audio nodes extracts and transcript the speech from video's audio track. We'll be using the PyDub and Google Web Speech API for transmission. And these are also stored in the JSON, and these two JSONs were sent to the data integration node. Data integration node integrates and sent to the report generation. So report generation, what it happens is we are using Gemini 1.5 Flash, and we are generating role-based reports using Gemini prompting. And here we're also supporting the multilingual supports, like the reports can be available in English, Hindi, Telugu, Tamil, Kannada, etc., etc., the local languages. Uh, so this is the thing. The novelty is like we have used a multimodal data integration. That is, we're getting the pose metrics and everything from the video analysis, as well as we are using the audio transmission. And we have used the LangGraph, which is a nice agentic AI framework, and we are getting the actionable granular feedback, like different type of feedbacks. We are getting the parent feedback, coach feedback, and the student feedback, and it is scalable and extendable architecture. And this is a technical stack which we used for the system implementation of the system. HTML, CSS, JavaScript for the website, and we have used a Flask backend technology. And for video processing, OpenCV. These are all the things. And these are the demos. Here we are uploading the video, and we are ready to analyze the things. The video is getting processed. This is the interactive report which we are getting, and this is a uh, PDF report which you can download. And these are the steps. Thank you. Now I'll be showing you the demo. It's the GitHub repository, the folders, and here we have the code, the pipeline, and everything. And this is the thing. Let me select sample2.mp4, and I'm entering my Google API key and generate analysis report. Here we can, in the console, we can see how the things were generated. So it has role equal to student and language equal to English. It has got this input, and the PDF is generated in English. And you can also download the PDF if required. And another functionality is like for English, I am able to download the PDF. I'm generate the PDF. I can also have, let's say, Tamil, and I'm entering the API key, and I'm generating the report. It will be working, but while converting into the PDF, as they are Devanagari script, it's not supporting in my system. In further, I will be improving so that you can also able to download the reports of Tamil. It takes time. And the terminal, we can see what is going on in the terminal. Yeah. So the audio was extracted, the video frames were done. Here you can see that language was Tamil, and role is student. So PDF is generated, but see, you can get the analysis in the Tamil, but PDF generated having some trash value. So I'm not as of now, I'm not keeping a feature for download PDF for this. As of now, the Tamil one, just I'm showing the things. Thank you. If you like my work, please star this repo and give any suggestions. I'm open. This is my mail ID. I'm open for suggestions and everything. Please do contact me. Thank you.